All right, good afternoon, you all. Once again, I could not be in class today because I am on site conducting tag testing, but I will be back on Tuesday. So, in lieu of a live class session, I have recorded this video that I would like for you all to watch for your class. In the Teams chat, you're going to respond to the bell ringer question. This will also serve as your attendance for class. So if you do not respond to this question, then you will not receive credit for being in class. And our bell ringer today asks in your own words, what are fossils? So go ahead and pause the video here to respond to the question, then come back and press play to continue the lesson. And as we look at our agenda, we're going to briefly go through our procedures and announcements. Today, we're going to be looking at fossil evidence in our mini lesson, and then you'll spend the remainder of your time for class working on your Canvas assignments. And with our announcements, remember that on Monday, March 16th, there will be no school due to the teacher PD day. So you all get a bit of an extended weekend, and I'll see you all back on Tuesday. Looking at our assignments and due dates, our 07.04A fossil and DNA evidence quiz is due tomorrow. So please be sure you're working towards getting that quiz completed. And if you have not yet completed your 07.03 evidence for evolution quiz, that was due on yesterday. So as we continue in our evolution unit, our standard is S7L5C, where we analyze and interpret data for patterns in the fossil record that document the existence, diversity, and extinction of organisms and their relationships to modern organisms. Our learning target states I can identify evidence of evolution. So today we're going to continue our studying of evolution with looking at fossil records. So it is hard to observe or even imagine species changing so drastically that they become entirely new species, especially since the process can take millions of years. After all, our Earth is around 4.5 billion years old. But we have many clues that tell us that evolution has happened and continues to happen. Remains or imprints of living things preserved in rocks are called fossils, and they are one of our biggest clues that life has evolved. Fossils help us map out when and where living things have been around, and they also tell us that the structures, such as bones or shells, haven't always been the same. Although there is a wide variety of animals, fossils show us how they share a similar basic body plan to many other animals. Fossils can be dated by examining the layers of the rock around it in a process called relative dating. The law of superposition tells us that new rock layers build on top of older rock. And this is something that we discussed last year in our earth science class as well. This provides us a timeline of species, and so far scientists have never found a fossil in the wrong date order. So you will never find the fossil of a mammal in the same rock layer as a trilobite, because that would not be in the correct order. And you will never find a fossil of a human below the rock layer or in the same rock layer as a dinosaur. What makes relative dating such a strong form of evidence of evolution is that it shows a consistent timeline for when species have been around compared to others. Fossils across the world trapped in this timeline show these similar patterns. We can estimate the age of bones and rocks in a process called radiometric dating. Over time, elements break down into other elements at specific known rates. After about 5,730 years, half of all of the carbon 14 in this bone will turn into nitrogen 14. And after another 5,730 years, half of the remaining carbon 14 in this bone will turn into nitrogen 14. Getting a timeline for when living things were around helps us develop a complete picture of how and when living things have changed. So in this image here, we see that we start off with a new bone, and after 5,730 years, we are left with the remains of those bones. And then in 5,730 more years, which brings us to 11,460 years, we're left with the remains. And then in another 5,730 years, we see how the bone continues to change. The time it takes for half of all of the elements to decay is called a half-life. Radiometric dating works with a lot of different elements, and it takes 5,740 years for half of all of the carbon 14 to break down into nitrogen 14. It takes 710 million years for half of the uranium to turn into lead. And it takes 1.3 billion years for half of all of the potassium 40 to turn into argon 40. Just remember that in real life, fossils and the rocks they are found in have way more than just 8 elements. They are made up of billions of atoms. So as we wrap today, our target has been to identify the evidence of evolution. You all are going to be working on your 07.04a fossil and DNA evidence quiz, as well as any past due assignments that you have. And if you have any questions, feel free to just message me in Teams, and I'll be more than happy to answer your questions there.